Hello everyone, welcome to this video by Data Science. So we will officially begin our course from today, and in the last course we discussed about what is DSA and why is it required. Okay, so that was a theoretical concept, and in this video we will dive into the architecture of code, how to compare codes, right? How to determine whether a particular code is good or not. So what is the science behind that? Okay, so you might have heard words like big O, time complexity, space complexity. So we will be discussing all that in detail in this particular video. So please tune into this, watch this full video. This is very important conceptually to understand, because before you begin coding, you need to know how any code works, how you determine. If you remember my last lecture, I said that DSA is all about writing an optimized code. Okay, and by optimized code, what do I mean? That code should have minimum time complexity, correct? So that it should run as quickly as possible, and it should have least space complexity as well. So these are the two things. We will discuss these two words in detail in this video, that what are they exactly, what do we mean by time complexity, what do we mean by space complexity. So please watch this video completely. Now before I begin, okay, I will like to ask you one thing. Let us say there are two codes. For example, here I have two codes present. So let's say there are two systems. So we are running two codes here. So once here we see run code 1, okay, and here we run code 2. In this particular, you don't so you run a particular code here, you run a particular code here. Both are doing, for example, both codes are generating same thing. For example, both are printing first and natural numbers. Okay, printing first and natural numbers, both of the codes. The code 1 takes, for example, 10 seconds, okay, to run, and code 2 takes 20 seconds to run. So just based on this observation, can you say that code 1 is better than code 2? What do you think about this? So just pause this video and think about a little, that I'm saying code 1 is taking 10 seconds, code 2 is taking 20 seconds to run. So can we say that code 1 is greater than code 2? So just pause this video, I'm saying again, and think about this, and then listen to my explanation. Okay, so now like a lot of you might have thought, yeah, definitely code 1 is running in 10 seconds and code 2 in 20 seconds, and they are doing the same activity. Okay, so ideally code 1 should be better than code 2. But there lies a big assumption, assuming that both these codes are running on the same computer, okay, and the computing power of that particular system is same. But that is not always the case. For example, you can take what if code 1 is actually very bad, but you are running it on a very good system. Okay, let's say the GPU speed or CPU speed of this is very much high, and let's say this is having 100 GB of RAM, okay, and this is only having a 1 GB of RAM, and that's why it is taking 20 seconds, and it is still taking 10 seconds. So even after 100 GB of RAM, this code is taking 10 seconds to run, whereas with 1 GB of RAM, this is taking 20 seconds to run. Okay, so that is something we can say, that code 1 is technically not better than code 2. Okay, so what do we infer from this? We infer from this that when comparing any two codes, time is not just measuring the time of run is not the right way to judge which code is better. Okay, so whenever we speak about time complexity, we don't mean that, okay, this code run in less time, so that code is better. No, we don't decide whether a code is good or not based on time. We decide it based on number of operations that particular code is performing. Okay, so we will discuss about this in detail right now, that what do you mean by number of operations. So for example, let us say we go to an example here. So this is a code 1 which is simply printing 1 lakh numbers. Okay, now if I run this particular code, you see, so what is this doing? This is let's not go in the concept what it is doing right now. Let's just run it. Okay, so it will just give me a sum of first 1 lakh numbers. Okay, so it ran instantly, and let's say I do the same thing here. So if you see, it is taking some time to run. Okay, it still has not produced the output for me. I don't know how long is it going to take. The code, like, it might hang my system as well. So what could be going wrong here? What do you think could be going wrong here? The problem I will discuss with you right now, that what is the difference between these two codes. So let me clear this particular board. Now see, if this code has not generated, like this code generated on my same system, this code generated me the result very instantly, and this code number 2 generated, it's still not able to generate. I don't know what's wrong. So the code is totally perfect, but it's still, I think it has hanged my system or something like that. So what is happening here? But let's say I reduce, for example, let's say I do 100 only. Okay, so let me just Control X this and Control V, and let me restart the kernel. Yeah, I think it hanged my system. Now see, now if I run for a small piece of number, it has generated me a good generated me a decent sum. So what did we see? That in the code 1 here, in the code 1, in both in the code 2 that we were running, in both codes we were generating the sum of first 1 lakh numbers. Okay, 1 lakh numbers. The first code generated like the sum in like hardly 1 second, not even 1 second, like 1 millisecond or something. And code 2, it ran for over, I would say, 2 minutes, or let's say at least 1 minute it ran, and it hanged my system. Okay, and it was still not able to generate. So what is good, even though they are running on the same compute, so we can definitely say that code 1 is better than code 2. But what is going wrong here? So that is the number of operation that each code is doing. So we will discuss that right now in this particular video. So let's see what is happening here. Here we are declaring total equal to 0, and we are creating a loop for num in nums. Okay, and we are just adding it to the total variable, and we are generating the sum. So what is eventually going on here is that there is a list. For example, let's say the list is 1, 2, 3, 4, 5, 6, 7. For example, let's say this is so on. Now what we are doing and this is the second code as well, for example. So 1, 2, 3, 4, 5, 6, 7, and so on. So what is happening with the first code is that it is running a for loop for num in nums. So how many, for example, let us say there are total 100. Let's say there are total 100 elements in both of these. Okay, so in first code we are just doing for num in nums, for num in nums. So how many times do you think it is going to generate? For example, let's say, so we will go here, we'll simply for num in nums, and we have here. So yeah, so this is actually running 100 times. So first of all, it will, an iterator num will create. So it will first go to this, then it will go to this, then it will go to this, then it will go to this, and then it will go to this, and so on. So how many iterations are there? Total iterations, if you see, there are 100 iterations, correct, in this particular code. So the iteration means number of operations that this particular code is doing. Whereas in this particular code, if we see the code number 2, what is happening, that there is a for loop, and inside this there is another for loop. So what is happening with the code 2 is that for I in something, and then there is also for j in something. Okay, so what is happening, for example, let's say this is 100, right? So what is happening, first I is equal to 100, and j will take all the values from 0 to 100. First of all, it will take that. So j will range from 100 to 1 to 100, for example. Now similarly, I will become, for example, after so after that, for example, let's say I was 0 here, then j will take these values. Now I became 1, then j will again take those 100 values. Okay, so I will take 100 different values, and for every 100 values, so I has 100 distinct values, and j is having 100 distinct values. So the total number of operation became 100 square, I into j, correct? So what did we see? That the number of operations that are happening in this is 100 square, that is 10,000, whereas in this it is only 100. And this is the reason why code 2 is taking a lot of time. Okay, so let me explain you through once again visually. For example, if you guys didn't understand, let me explain this thing once again. So let me clear the board. So let me restart it. I don't know what is going wrong here. Okay, so I will just log in once again to this. Yeah, so let's see what is happening here. That let's say that list is, for example, let's say reduce that number. Let's say the list is only having 5 elements. So 1, 2, 3, 4, 5. In step 1, in the code 1, what we are doing, we are simply for num in num. So first of all, num will take equal to 1, then num will take equal to 2, then it will take 3, and it will print up to 5. So let us do one thing. Let us try to compare, see that code here. For example, in the code 1, what we are doing, that let's say the list is equal to 1, 2, 3, 4, 5. Let's try to print all the operations. So what is happening for num in list? Okay, we are printing num, for example. So what it will do for every iteration that it is going to do here, first and 1, 2, 3, 4, it will print me all the iterations. So how many steps are there? Total 5 steps are there. Okay, in this particular method. But in code 2, what is happening? So in the code 2, we are doing for num in this. So first of all, we are doing for I in, so let me write on the code 2 here. So Control C. So in the code 2, what we are doing, that for I in range length of list, okay, and for j in range 1 to length of list. So what we are doing here, we are, let's say, printing I. So we are doing list of I, comma list of j. Okay, so let's say we print this. So this will show me the for j in, okay, I didn't close this, just a second. So see what is happening, how many operations are there. So one total, there will be so let's say, even if I don't do this, something like this I do, for example. So how many steps are happening? I is going from 1 to 5 and j is also going from 1 to 5. If you print, this particular code is taking 25 steps. Okay, because I is varying, first of all, 1 to, when I is constant 1, then j is taking all the values. When I is 2, j is again taking all those 5 values. Okay, so what is happening, it is taking 5 into 5. So here it is taking 5 into 5 steps, that is total 25 steps. And that is why code 1 is better than code 2, because code 2 is doing 25 operations and code 1 is doing only 1 operation. And this is how we decide whether a code is better or not. And this is called the time complexity, that the number of steps that your code is going to take, that is called as time complexity. Okay, it is not how much time is it going to do, it is number of steps, or you say number of observations, or number of, like, whatever you can name it, anything. Okay, so how many steps your code is going to take, that determines whether your code is good or not. And this is what we have to reduce by learning concepts in this particular course. Okay, so this is called time complexity, that whether your code, if there are two pieces of codes, the code, let's say both codes are doing the same work, the code that takes less steps, okay, that does less observation, that code is better than code number 2. So this is the basic intuition of time complexity. Now let us understand the concept of space complexity. So space means how much storage your particular code is going to do on the server. So for example, let us, again, we have two codes, code 1 and code 2. Okay, and both, let's say both are working on a single server. So let us say this is my server. Okay, here in my server, and it is divided into 6 partition. Okay, like every server, if you know, it is divided into certain partitions, and this is my core 2. Okay, here for this is also there is a 1 2 3 4 5. So what happens when code 1 runs? Okay, it is going, so out of 5 it is going to take, let's say, 4. So it is taking 4 out of 5 partitions, whatever variables you are declaring, what everything you are storing in 4 of the partitions, whereas code 2, it only stores in 2 out of 5 partitions. Okay, so what does it mean? That code 2 is taking less space as compared to code 1, and in terms of space, code 2 is having a greater space complexity, better, I will say better space complexity than code 1. It's like theoretically, conceptually, it means same. How much storage, whenever your code runs, how much storage is it going to do on a particular server? So whether you are storing, so remember, like when you code, it is always good advice that don't store unnecessary files on the system while writing the code. For example, in SQL, if you remember, we create, there's a concept of views we create, that whenever you have to create any temporary table, or there is a concept of CTE in SQL, right? So what all these things do, that they temporarily create tables, they do not store them anywhere on the server. Okay, and because of this, the code runs in a better, like with better space complexity. So this is the concept in Python as well. So let's walk through 2 codes. Okay, so this is the code 1. So what is happening in both of the codes? So we'll discuss 2 codes here. In both of the codes, we are finding the maximum in a list. For example, this is a list 10 3 56 this, and we have to find the maximum number. So let us try to understand what are we doing in code 1. In code 1, we are first of all defining something. Let's say that the first number is the largest. Okay, so what we have done, we have assumed that 10 is the largest. Okay, and then we iterate for each number, and if any number is higher than that, then we assign that maximum to that particular number. Okay, so at any time, max num is only containing one value. So let me explain you through this visualization, right, so that you understand it better. So let me create it here. So what are we doing? So let's say the list is 10 3 56 32 95. Okay, so let's say the list that I'm having is 10 3, just let me check it, 56 32 95. Okay, so 56 32 9 and 5. So let us say this is my list. Now what is happening in the code 1, what we are doing, that we are temporarily creating a max variable, max value, not a variable, which is equal to a single value, which is equal to 10 initially. Okay, and what we are doing in the further step of the code, that we are iterating from here to here, right, and we are comparing. If a particular number is greater than 10, we are changing the value of max to that variable. So for example, this particular code will run 1 2 3 4 5 6 times run, right? So in the first iteration, the max value is 10. In the second, max value still remains 10 because 3 is still less than. Now we come to this, then max will update itself to 56, correct? And in fourth, it will remain 4 5 6, it will remain same 4 5 6. The max values will still remain 56. So what do you see? The max variable that we created, it only consisted of one value at any point of time. There was not it never consisted of 2 values, right? It was 10 first, then it changed to 56, and it remained same throughout. So there was only one value inside this max value, correct? So for example, let's say this was my server, and let's say this server had 10, for example, 10, or let's say 5 partitions, 1 2 3 4 5. So this particular is only taking one out of that. For example, let's say this is only picking this much space, because at any time I am storing only one value in this particular part. Now let us see the second code. What we are doing in the second code, we are creating a temporary list. Okay, and first of all, we are adding all the numbers into that list. Okay, and then we are doing the same step that we did in step 1, that we are creating something. So what additional we did in code number 2? We created a temporary list 2 here. So if I talk about server, now let me remove this particular part. So let me erase this. So what are we doing in this particular is that, first of all, we are creating a list, temporary list of length, for example, 1, 2, 3, whatever list n that we are creating, and then we are storing in a max variable. Okay, so there are two entities are created. One list is created and max is created. Max was present in previous, so max was taking one space. This list additional that we have created temporarily, this will take two more let's say partitions, right? So overall the space complexity of this particular code will become higher, correct? Because here we declare one additional list which takes more space on the server, and that's why my code 2 is like it's not good. Like code 1 is better than code 2 in terms of space complexity. So this is what the concept of space complexity is, that whenever in your code you are declaring unnecessary additional variables, data structures, for example, right? So here we just created one variable which only took one space, but here we created two variables. One took space 1 and one took space 2. Total 3 space it took, right? So overall the space complexity of code 2 got reduced. So this is also we have to keep in mind while writing code, that we don't declare unnecessary variables, and so that my code runs faster, because the lesser your space your code is going to take, the better time complexity it will have, right? Because it will run a little faster. So we discussed about the two concepts, time complexity. We just discussed about the intuition. We will discuss in detail in this particular course, but we discussed just about what do we mean by time complexity and space complexity. Okay, so this is something we need to minimize, and in this particular course we are going to focus only on time complexity, because space complexity, it is not asked, to be honest, right? And it is rarely checked. So if you can run your code with a good time complexity, it is considered good. So we'll be entirely focusing on time complexity, because that is what the course is all about. Okay, space complexity you do not need to know in detail. Wherever it comes, I will cover it, but we need to mainly focus on time complexity. Okay, so this was the introduction of time complexity and space complexity.